Book notes for Effective Computation in Physics by Anthony Scopatz and Kathryn D. Huff. I'm filming this Thursday, 10 October 2024. I'm Tanis Coralee Leonhardi, she, her, hers of Norway in United States of America. And 2 days ago, on Tuesday, 8 October 2024, a Nobel Prize in Physics was awarded to, or classified as the category of computational physics. And then yesterday, Wednesday, 9 October 2024, the Nobel Prize in Chemistry went to computational chemistry. And both are physics and chemistry using computational methodology or developing computational methodology. And I was like, what about you? Do you want to be able to do computation in physics? Do you want to be able to do computation in chemistry? And I was like, do I got something that I can provide to you as a resource? So, to wrap up this introduction, this is a book that I bought when I was in graduate school, geophysics, and I have used a number of programming software programs / languages, C, C++, MATLAB, Python, stuff like that. And so this is one of the resources I bought when I was in graduate school for using Python. Now, Python, personally, for what I have done, I primarily used for plotting. It can absolutely beautiful plots can be made with Python. And so about this, and it has, well, like I said, it's book notes. So it's a good resource if one's just interested in what the heck is this? What can it be used for? It's an instructional book on how to use Python for computational methods in physics. So this is Effective Computation in Physics by Anthony Scopatz and Kathryn D. Huff, June 2015 O'Reilly Media Inc. edition. Paperback, ISBN in the video description. Book notes including construction and design. So it's very much designed with the student in mind. There's glossary, index. The book is broken into different exercises and kind of different components of computation, things that people might not really think of. They think of, oh, I gotta write a code or I gotta write a program. But like, for example, chapter 10 is on storing data. Like, if you're trying to pipe a certain file, it matters where is that stored and where in your file directory that's located, right? Yeah. So, and what file type you're using is that, can whatever you're doing process that using whatever you're invoking. Then chapter 17 is on debugging. So once you've written a code, that's nice. That doesn't necessarily mean it's right. All right. So how do you find out what you got wrong? And so, I also have a section, chapter 7, on analysis and visualization. So it goes through these different topics and it provides step-by-step. This is what we're trying to do. This is kind of what the syntax or semantics look like. This is what to write into your code, and then go through each of these different steps and you try and figure it out. All right. So there's sometimes it's providing, here's actually, you know, the text you should use, and sometimes it's using, let me just, you know, it'll say, give you a direction or a command, and so then you do that, but you have to come up with what you actually need to write in the code itself. I personally, with my own experience in using Python, if I'm working on a plot or a graph or whatever it is, and it's very particular, then I might search for like very specific targeted, how do I do blank in Python? It's pretty well known in certain communities. The text, so in the book, it's helpful for just flipping through. It has the chapter and then kind of overarching theme on the bottom along with page numbers, and that's stylized so it's easy to differentiate it from the text. There's a combination of just plain text, tables, visuals, and then examples of code you can put into Python itself. It is instructional, and there are exercises, and the whole book is kind of like just a huge resource on exercises. But you can think of it as And how many pages is it? People want to know headlines. Over 500 pages. It's 520 pages, including the index, 521, including the about the authors section, and colophon. So, colophon goes on to the second page. 522 pages. And stuff like this can be, the physics, you know, is, there's equations, and those equations can be solved manually, like by a human, can also be solved computationally. But some people really struggle with that, even with a physics degree, especially if they haven't taken computational physics and they don't understand how computers can be used to actually go through an equation and help figure out the underlying physics, right? In addition to a computer is made of physical parts, right? So there's also that kind of computational physics in terms of how does one even come up with the physics that defines a pixel, right? Pixels didn't always exist. Physicists came up with what a pixel is. They made it. They generated it. They created it, right? So, in the science that created it. So, some people really struggle with that, even if they claim to be a physicist. And they might say it's not physics. They just lack that understanding. And so this is a good book for like getting familiar with just, you know, what kind of physics can a person do with a program such as, or software, whatever one wants to call it, coding language, programming language, whatever you want to say, with Python specifically. So in conclusion, it's a good resource. It's good for getting an introduction. Python itself, can search in the internet, the interwebs, and find more specific things that might be more relevant, but it is good for introductions. And I have used matplotlib a lot. Yes, so in my own research, so in physics. So there we go. Book notes for Effective Computation in Physics by Anthony Scopatz and Kathryn D. Huff.